Section 8.3, the phase rule. It's a very simple equation. It's F equals C plus 2 minus P. F is the number of the degrees of freedom. P is the number of coexisting phases. And C is the number of chemically independent species. If you have just one chemical, C is 1. If you have two chemicals, C is 2. Unless there's a chemical equilibrium between these two chemicals. So if you have NO2 and N2O4 at equilibrium, well, C is still 1 because they are not chemically independent. However, if you put nitrogen and oxygen and water vapor in the same system, you have 3 independent species. Now let's look at the equation. First, what is the number of degree of freedom? Let me show you a picture. If you see a line, that means the pressure depends on the temperature. There's only one independent variable. You have 1 degree of freedom. Well, if you look at this area, okay, the P and T can both change freely. You have 2 degrees of freedom. Now, if you look at just this data point, it's a point. It's a triple point. There's no freedom at all. So the freedom is 0 here. Again, if you see a dot over here, this is a triple point. It has a 0 degree of freedom. And remember the phases law, it's F equals C plus 2 minus P. In this case, we have only one substance, that's water. So F equals 3 minus P. You have 3 phases coexist. So what's the degree of freedom? 3 minus 3, that's 0. Along this line, you have 2 phases coexist. So the number of degrees of freedom is 3 minus 2, that's 1. You have 1 degree of freedom. Yeah, it's true. At least one of the 2 variables, P and T, can change. However, the other variable does depend on the first variable you choose. Okay, so you can say, well, I can change temperature freely, right? If you can change temperature freely, you cannot change pressure freely along this line. Or you can say you can change pressure freely from lower pressure to higher pressure. But then you can't change the temperature freely because this is a coexistence line between liquid and vapor. But however, if you look at this region, again, it's just the vapor. There's only one phase. You can move freely. You can change temperature. You can change pressure from here to here or here to here. Okay, that's just, you have 2 dimensions here. You have 2 degrees of freedom here. And again, F equals 3 minus P if you have only one chemical. So 3 minus 1, that's 2. You have 2 degrees of freedom. Yes, the pressure and temperature, you can change them freely. So that's what this phase diagram is about. Now, what if you have 2 chemicals? Well, if you have 2 chemicals, let's say if you have nitrogen and oxygen, and then the number of freedom is equal to 4 minus the pressure. So let's say if you, 4 minus the number of phases. So let's say if you have nitrogen gas and oxygen gas, in the gas phase only, there's only one phase, the gas phase, and they're mixed. And then you have, actually this time, look at this equation. 2 chemicals. 2 plus 2 minus 1. Only one phase. And then you have 3 degrees of freedom for the mixture of oxygen and nitrogen. So in that sense, you can have 3 independent variables that can also that can change freely. I mean, you can change pressure, you can change temperature, and you can change the mole fraction of the nitrogen and oxygen freely. So the 3 of them. Alright, so that's 8.3. But again, I mean, this could be confusing. Chemically independent species. Again, if you can write one chemical equation between the involved species, you need to subtract this C by 1. Okay, the degree of freedom will also be reduced by 1. So that's 8.3. All you need to do is, for most systems, there's no chemical reaction, and then you just memorize this equation. The number of freedoms is equal to C plus 2 minus P. The number of independent chemicals plus 2 minus the number of phases. If there's only one chemical, the degree of freedom is just 3 minus the number of phases. You can easily verify this equation given any phase diagram of a pure substance such as water, like this. You look at the triple point, you look at the coexistence line, you look at the area, and that helps you to memorize these two equations.